Organic recycling. Soil is an important, non-renewable natural resource which provides very complex life support system. Although sugarcane needs a well-drained loamy soil with neutral soil reaction for its ideal growth, it is grown in widely varying soil environments. Soil organic matter, being one of the soil constituents, helps in better soil structure formation and provides the most favorable air and water regimes. It is the source of plant nutrients, including micronutrients, which are released in available form during mineralization. It increases the water holding capacity, buffer and exchange capacity, and microbial activity of the soils. Soil organic matter content can be improved and maintained by liberal application of green manure, green leaf manure, farmyard manure, compost and bulky organic crop residues. Sugarcane crop yields substantial quantities of organic matter in the form of trash, roots, stubbles, press mud, bagasse and effluents. Sugarcane produces huge quantity of foliage, about 40% of the total biomass. On an average, the cane trash produced amounts to 15 to 20 tons per hectare. The nutrient content in 1 ton of cane trash amounts to 3.5 kgs nitrogen, 1.3 kgs phosphorus, 6.5 kgs potassium and appreciable amounts of micronutrients. Usually, sugarcane farmers dispose of the trash by burning in the field itself. This is mainly because of the requirement of huge number of laborers to remove trash out of the field and also due to lack of appreciation of the value of the trash. When the trash is burnt in the field, the environment is polluted. Burning trash generates intense heat which kills favorable soil microbes and earthworms. This affects favorable soil biological activity. All these undesirable effects on soil, environment, loss of nutrients, etc. could be avoided by recycling trash through composting. After the cane is harvested, collect trash and move it to a corner of the field or to any other convenient place. Spread trash to a width of 3 meters and a length of 7 meters to a height of 15 centimeters. This dimension is for about 100 kg trash. Over this, spread about 100 kg press mud. Mix 5 kgs rock phosphate, 4 kgs gypsum and 1 kg urea along with 10 kgs of well-decomposed farmyard manure or compost and 10 kgs cow dung. Sprinkle this mixture over the trash press mud layer as a starter. Then moisten the entire layer. Repeat this process till the heap reaches 1.5 meters height. Then cover the top layer with a mixture of soil and press mud to a height of 5 centimeters. Maintain moist condition at 50% water holding capacity throughout by sprinkling water at 10 days interval. After 3 months, rake the contents, mix thoroughly by spade and again heap. At the end of 5th month, the trash becomes a good compost with narrow carbon nitrogen of 10:1 with a nutrient content of 1.8% nitrogen, 0.51% phosphorus, 0.2% potassium, 1.2% calcium and appreciable quantity of micronutrients. Press mud is another byproduct of the sugar industry. The press mud produced in a sugar mill is about 4% of the cane crushed. The press mud contains considerable amount of major and minor nutrients. Application of press mud improves iron availability. It also improves availability of zinc, calcium, magnesium and manganese. In calcareous soils, it reduces soil pH, electrical conductivity, exchangeable sodium percentage, and increases nutrient available status of the soil. Immediate and direct application of press mud is not desirable as it has a wide carbon-nitrogen ratio and its decomposition generates a lot of heat. Composting of press mud using microorganisms helps in enriching it and makes it easier and safer to apply in the field. A rapid technique for decomposition and enrichment of press mud using microbes was developed at Sugarcane Breeding Institute. Spread fresh press mud to 3 meter length and 1 meter width depending upon the quantity to about 15 centimeters thickness. Prepare a microbial culture of 1 kg pleurotus or Trichoderma viridi, 5 kgs urea and 50 kgs cow dung per ton of press mud by mixing them in water. Sprinkle this slurry over the press mud as a starter. Then add another layer of press mud to a thickness of 30 centimeters over the first layer. Again sprinkle microbial culture, urea and cow dung. Repeat this process till the heap reaches a height of about 1 meter. Cover the top layer with soil. Sprinkle water to moisten it to 50% water holding capacity. Maintain this moisture level throughout. Decomposition will be over within 6 to 8 weeks. Rock phosphate, ferrous sulfate, zinc sulfate, etc. can also be added to improve the nutrient content. The press mud thus composted is dark in color with narrow carbon-nitrogen ratio of about 10:1. This decomposed press mud can further be used as a source of inoculum for further decomposition without the addition of microbial culture. The ratio of the inoculum is 1 ton for every 5 tons of fresh press mud. Vermicompost is a compost manure produced with the help of earthworms. The earthworms eat agricultural wastes and produce vermicasts, which is a good manure. The press mud and bagasse can be fed to the earthworms and good quality vermicompost can be produced. For composting, make a pit of suitable size. Mix press mud and bagasse in the ratio of 1:3. Release the earthworm Lambido maruti into the pit at the rate of 2000 numbers per ton and spray water. Maintain uniform moisture at 40%. To minimize loss of moisture and nutrients, put a thin layer of sand cover over the compost pit. In about 4 months, the compost is ready for use. Vermicompost thus prepared has been reported to contain 340 ppm calcium, 348 ppm magnesium, 4400 ppm sodium, 12,800 ppm potassium, 78 ppm iron and 74% organic matter. Regular use of organic manures such as trash compost, enriched press mud and vermicompost using press mud and bagasse helps in improving soil organic carbon content and nutrient availability.